Welcome to Yoshitake online seminar. Today's topic is advanced version of PRV for water. In this presentation, I will explain how to check specification and performance. Here is the contents: flow characteristics, pressure characteristics, and summary. When you receive the inquiry from your customer, we do not talk about the flow characteristics. However, when we look at the instruction manual and catalog, you can see the flow rate characteristic chart. This presentation is an advanced version of pressure reducing valve, and hope that you will understand the pressure reducing valve in deeply after listening this presentation. Before I explain the main part of the presentation, I would like to explain what is PRV. It is a regulating valve that keeps outlet pressure of the fluid at a certain and lower level than inlet pressure, responding to low fluctuations. Limitation and fluctuation occurs due to the characteristic of the fluid and expressed as flow characteristics and pressure characteristics. First, I would like to explain about the flow characteristics. Fluctuation in the reduced pressure while flow rate varies of outlet pressure when inlet pressure maintains at constant pressure. When we read this sentence, it's difficult to understand. So let's have a look flow characteristic chart of GD26NE. Here is the flow rate. Here is the reduced pressure. When the flow rate is becoming bigger, the set pressure, the outlet pressure is dropped slightly. The function of pressure reducing valve is to maintain the outlet pressure at a stable. However, the outlet pressure will drop slightly. Flow characteristic chart is showing that kind of changes. Let me explain in detail using the same graph in the next slide. In this slide, I will use flow characteristic chart and pipeline to explain flow characteristics to easy to understand. First, please have a look at the pipeline. The water flow from the left to the right passing through PRV. First, we need to set the pressure for PRV for water. For setting pressure or pressure reducing valve means that we need to adjust the pressure on the water flow. So it is adjusting the pressure under the slightly open saturation of the outlet valve. The minimum flow rate that can adjust pressure is called minimum adjustable flow rate. For GD26NE, the minimum adjustable flow rate is 5 liters per minute. The pressure at the minimum adjustable flow rate will be the set pressure. From this saturation, when you open the valve liter by liter, the flow rate will be increased. Please have a look on the right side of this graph. It will descend slightly, and then when the flow rate reaches a certain point, pressure drop suddenly occurs. If the pressure drop suddenly occurs, it is a difficult area to perform the pressure adjustment function as a pressure reducing valve. So it is necessary to draw a line of performance before that. The line here is the rated flow rate. The pressure drop from the minimum adjusted flow rate until to rated flow rate is called offset. This offset depends on the model of the pressure reducing valve, but the offset pressure is around 0.1 megapascal or 0.15 megapascal. After looking the valve opening, this time you will look the valve closing saturation. When the valve is closed, the pressure return valve to the set pressure, and then considering the valve is fully closed. The flow rate will be 0, so the pressure will rise above the set pressure. That pressure is called shut-off pressure rise. For GD26NE, the shut-off pressure rise will be 0.02 megapascal. The pressure reducing valve is used, the range between minimum adjustable range and the rated flow rate. If there is exceeding the rated flow rate, the pressure reducing valve cannot adjust the pressure and cannot maintain a constant pressure. This is rated flow rate. For example, 25A of GD26NE, the rated flow rate is 60 liters per meter. This is flow rate chart for choosing the size. When we do not know the size and we only have the information flow rate and reduced pressure, by using the rated flow rate, we can choose the nominal size. This is the CV value definition. The valve flow coefficient CV is defined as the flow capacity of water at 60 degrees Fahrenheit in US gallons per minute when it is flowing through the valve with a pressure difference of 1 psi at the operating range. So CV volume is the indicator of the rate of flow of valve. If the CV value is large, the flow rate will be bigger. This CV value table is shown in Technical Guide both version 4. The page is 1-14. It is not only for steam, and also you can check for the air as well. This slide will explain about pressure characteristics. After keeping the inlet pressure at constant pressure and setting the outlet pressure, the pressure change in outlet pressure due to the change in the inlet pressure. If we read this sentence, it's not easy to understand, so I will explain using this graph. So this is the pressure characteristic chart of GD26NE. The horizontal is inlet pressure and the vertical is reduced pressure. The inlet pressure is 0.6 in here and the outlet pressure is 0.1 megapascal. When the inlet pressure changes from 0.6 megapascal to the 0.15 megapascal, the outlet pressure also will change. When the graph goes to the left side, the pressure will decrease. So it means from 0.6 megapascal to 0.15 megapascal, the reduced pressure will be 0.095, changing from the set pressure 0.1 megapascal. When the pressure goes to the right, from 0.6 megapascal to 1.0 megapascals of the inlet pressure, the reduced pressure will be increased from the set pressure 0.1 megapascal to around 0.105 megapascal. So This graph is showing the changes of reduced pressure due to the changes in the inlet pressure. So I will explain why this occurs using this pressure characteristics slide. The left is GT26NE for water, the right is GB1000 for steam. For GB26NE, the reduced pressure is increased when the inlet pressure is increased. For GB1000, when the reduced pressure is decreased and the inlet pressure is increased. Because of the valve structure, the pressure characteristics is different. For GD26, the water will flow from the left to the right like that. There is valve that adjusts the opening and closing where water passes in. Valve this GD26 ending is valve opening when the water flows. For GB1000, the steam flows same as GD26 ending from left to the right. Valve, the valve is closed when the fluid is flowing. So, what is the difference between GD26NE and GB1000 is that GD26NE is valve opening and GB1000 valve is closing when the fluid is flowing. This is a summary of the pressure reducing valve. Fluctuates slightly depending on the flow rate and pressure reducing valve. Use the pressure reducing valve below the rate of flow rate. The set pressure of the pressure reducing valve may need to be finally adjusted on site. Thank you so much for attention for this presentation. If you have any question, please contact our distributor or you can contact directly to us.